Hello, Stat. I'm going over the answers to the multis practice chapter 8. Assuming I didn't have time in class, I showed you the overall answers. I'll show those to you again. See if I can get out of the shadow. I can't. Number 10 was too bratty for words, so I'm not giving you the answer to number 10. Just ignore it. Alright, on number 1, we are given some information. We have a 95% confidence interval for P, and the parameter of interest describes how many purchased cookies, what percentage at a large grocery store purchase cookies. And here is the confidence interval that had been determined by the problem, and they want to know the point estimate and the margin of error. So you recall, when we have an interval like this, a confidence interval, the point right in the middle is the point estimate. So I'm going to subtract these two. I'm sorry, to get the one in the middle, I'll subtract it in a minute. But to get the one in the middle, I add the two numbers and divide by 2. When I did that, I got 0.259 for the middle number, and that is my point estimate. And then to get the margin of error, that's this side, I'm going to subtract 0.282, that's this number, and I'm going to subtract from it 0.259. When I do that, I get 0.023. And that is going to correspond to selection E. Alright, number 2 talks about following statements. Which one is correct? So, the following statement, A says 95% of the shoppers have between 23.6% and 28.2% chance. So whenever you see the word chance, I would shy away from that answer. So we're not talking about probabilities or chance when we're talking about a 95% confidence interval. So it's going to be hard for me to get them in so that you can see it well on the screen, but because this said the word chance in it, we are going to shy away from it. On the next one, I see probability, another word that I'm going to shy away from. And here, chance, and on letter D, the confidence interval indicates that more than 25% of the shoppers buy cookies. Has nothing to do with that, and so hopefully it is the last one. It says we are reasonably certain. So does that correspond to we are 95% confident? I'm going to say it does, that the true proportion of shoppers who purchase cookies is between 24 and 28%. There we go. Bingo. So we're going to select E for number 2. Number 3. Which of the following would be true about a 98% confidence interval constructed using the same data? And number A says the interval would be wider. All right, so we're going down from a 95% to a 90. I'm sorry, we're going up from a 95% confidence to 98% confidence. And we learned from the Garfield principle that the wider the interval, the more confidence we have. So we're going to look for an answer that says wider. So I see one on A and I see one on C. So let's read those two. The interval would be wider because the standard of error would be larger, or C, the interval would be wider because the critical Z would be larger. So which one of those is going to create the bigger confidence interval? And the answer is C, because if you look up Z star for 98%, you'll see that it is a larger number than it is for 95, and that will create a larger interval. Alright, so the answer to that one was C. Just to re-emphasize, remember when they're talking about the confidence interval, you're going to have p hat plus or minus z star times p hat 1 minus p hat over n under the radical square root. So for number 3, they were saying, well, what's going to cause this to increase? We've been well taught that from 95 to 98 will make it increase, but mathematically, why will it get wider? Why will this whole expression get wider? And it's either going to be this gets larger or the standard error gets larger. And it turns out that this is the only thing that changes when we go from 95 to 98. So, all right, enough on that one. On number 4, it says, talking about the government claims that students earn an average of 4,500 during their summer break from studies. So a random sample of students gave a sample average of 3975, and a 95% confidence interval is found to be between those two numbers. Which of the following is correct? Interpretation of 95% confidence. All right, so I see in A the word probability, shy away. On B, I see, because our specific confidence interval does not contain the value 45, there is a 95% probability, so let's shy away from that. If we were to repeat our survey many times, then about 95% of all confidence intervals will contain the value 4,500. All right, if we were to repeat our survey many times, then about, okay, so they are, what's wrong with that one? That one was tempting for me, but I see that the word, the number 4,500 was there, but it should say, to be true, if we were to repeat our survey many times, then about 95% of all the confidence interval will contain the true mean. So we don't know what the true mean is. All we know is what they claim to be the true mean. So we're going to put C on hold. It's probably not the right one. On D, if we repeat our survey many times, then about 95% of our confidence interval will contain the true value of the average earnings. There, that's better. So D, I don't have to look any further. That is just word perfect. So D it is. All right, on number 5. It says you want to estimate the mean SAT scores for a population of students with a 90% confidence interval. Assume the population standard deviation is, if you want a margin of error to be no more than 10, you'll need a minimum sample size. Okay, so we've done quite a few of these, so let's see if this one works well. So we're going to take that part, since the standard deviation for the whole population is known, which is really wacko, but that's okay. We can handle it. So you're going to use a z-interval, and this is for the mean. They mentioned the mean of the SATs. So we're going to take that, and we're going to say that they wanted the margin of error to be no more than 10. So we set that up and just solve it for n. So putting in z star for 90%. Remember how you look that up? We're going to be 90% in here. So outside is 10%. 90% under the curve, 10% out on both tails. So that would mean 5% on each side. So we need this number or this number. It's easier to look up this one. So 5%, we're going to look up in the body of the chart 0.05. So when I did that, I came out with 1.645 for that number. And then I had the standard deviation was known to be 100. And there were, how many in this sample? Okay, that's what we're looking for. Okay, wake up. All right, so now we just solved that. If you recall, we take 1.645 times 100 divided by 10, and that will come out to a number that is less than or equal to square root of n. So I'm going to remove square root of n on this side. This inequality is still in that direction. This divided by 10 is 10. 100 divided by 10, when I bring this over, I get 1.645 times 10, so I get 16.45. So I like to switch that around. Square root of n is greater than or equal to 16.45. So when I square both sides, let's see what I get. $270.6. So now that's after I squared it. So I have n is greater than or equal to 270.6. So I want a number to tell my company. So not because it's 0.6. If there's any part of a decimal here, I'm going to round up. Because if I round down, I might not be within 10 for our margin of error, so we want to stay within that. So we can always do that by rounding up. So I'm going to tell the company, get a sample of 271. Hopefully that is one on our list. Yay, it is. So that 271 is selection C. All right, number 6. All right, on number 6, it says the government does not. Wrong, number 6. All right, it says an SRS of 50 students at a large middle school are asked, do you have a television in your bedroom? And 28 of the students responded yes. So if p hat is the proportion of students who answered yes, what is the standard error of p hat? I love these standard errors and margin of errors, so we're going to love them too. So since we're in p hat land, we are going to grab this value, p hat 1 minus p hat over n, and that is just our standard error. So in this case, there were 50 students that were chosen, and 28 said that they had a bedroom TV. So that turns out to be 0.56. So you have to calculate the proportion so we can put it in here. So we get the square root of 0.56, and 0.44 would be 1 minus 0.56 over the square root of n, which, well, not over the square root of n, but within the square root is n, 50. So calculating that, I got 0.070. Hopefully that's one of our selections. Yeah, it is. It is selection C. So number 6 came out to be C. Number 6 came out to be C. All right, number 7. A college newspaper of a large Midwestern university periodically conducts a survey of students on campus to determine the attitude of on campus concerning issues of interest. Pictures of the students interviewed along with the quotes of their responses are printed. Students are interviewed by a reporter roaming the campus, selecting students to interview haphazardly. On a particular day, the reporter reviews 5 students and asks them if they feel there is an adequate student parking on campus. 4 say no. Which of the following conditions for inference about a proportion using a confidence interval are violated? So on this one, on number 7, we're looking to check the conditions, which are RIN. So the first one is, so before I even look at the answers, let's just discuss RIN, and then we'll go back and pick our answers. It is not randomly chosen. Walking around and haphazardly picking people is not a random selection. So they failed on that. All right, so the second requirement is independence. So they picked 5 students. So 5 times 10 is definitely less than the population of students. So we can assume independence. Is it normal? So when we're looking for a proportion of people who said something, we have this requirement, n times p. In this case, p hat is greater than or equal to 10, and n times 1 minus p hat is greater than or equal to 10. So we had 4 out of 5, so we had 5 total, and the proportion was 4 out of 5, so that gives us the number 4. So that is not greater than or equal to 10. And then the balance is, there were 5, and 1/5 was 1 minus 4/5, so that gives us 1. So that's not greater than or equal to 10 either. So it's not greater than or equal to 10. So it looks like there's some violations. Let's see if what they said lines up with that thinking. Number 1, we're looking for which conditions are violated. And the data is an SRS from the population of interest. It is not a random sample. So they violated 1. Well, number 2, the proportion is at least 10 times as large as a sample. That one was fine. Number 3, we did not pass normality. So therefore 1 and 3 were violated. So that is selection D. All right. So number 7 was D. All right, number 8. We're looking at a T confidence interval for our population mean. They said it is robust with respect to which of the following concerns. And they said undercoverage, lack of randomness, skewness, and the presence of extreme outliers. Well, no confidence interval of any type will be of any value with undercoverage. So if your sampling method is flawed, it's not going to be, we're not going to be able to overcome that. So we cannot say that a T is robust against undercoverage. Nothing is. So remember, robust means that you can use the procedure even though the condition is violated. How about lack of randomness? Again, that's a sampling error, and no interval can be conducted with any amount of confidence. Now in C, I was kind of questioning that because it doesn't say how much skewness. Skew in the population distribution. If it's a small amount of skewness, then it is robust against it, but if it's a large amount of skewness, then it is not. So I am noticing it says skewness in the population. So what we learned was about skewness in the sample. So I'm going to think on that one. That might be good. Number D, or letter D, the presence of extreme outliers. The T procedure is not robust against that. And none of the above. So I have to decide whether to choose skew in the population distribution. And I notice when I take a skewed population and I'm going to actually take a sample from it, if the sample's large enough, the skewness goes away and it becomes normal. The sampling distribution becomes normal. But they are not telling us how many were in the sample, so they're just saying the confidence interval for a population mean is robust with respect to which of the following. And it says skew in the population distribution. All right. I'm going to ask you to assume that skewness is mild and that n is large, so we're going to go ahead and go with C. We did make some assumptions there. If you chose E, I would give yourself credit because your thinking is probably also correct, assuming that there's enough skewness that will, and then n is small enough, we're not sure, so how could we choose C? So the book chose C, but it's very bratty. So C or E for the reasons discussed. All right, suppose the population of the scores of all high school seniors who took the SAT math test this year follow a normal distribution with a mean, mu, and standard deviation of 100. You read a report that says, on the basis of a simple random sample of 100 high school seniors that took the SAT test this year, confidence interval for mu is. The confidence level for this interval is. Okay, so this will be a good one. I think we can just do it with math. So I notice on this one, we are talking about mu. And so I'm going to be using a x-bar interval. And standard deviation for the whole population is known. So it's going to be a z interval. So I'm going to have this is what has been calculated. Come on, pen, one more problem. Plus or minus z star times the standard deviation, which is known, divided by the square root of n. So that's going to match what they said. And they said they got 512 plus or minus 25.76. So x bar must be the 512, and this whole thing, the margin of error, must be this 25.76. So if I keep that in mind, let me set that up. Suppose I say 25.76 equals z star, standard deviation, which was given as 100. And how many were in the sample? There were 100. All right, so square root of 100 under the bottom here, square root of 100. All right, so I filled in what I know from the confidence interval. I just took this side, the margin of error, because I knew it had to match this number. So they want to know the confidence interval. So let me solve that for z star and go from there. So this is 10, that's 100 divided by 10, so move that over, and I get 2.576 equals z star. Alright, so 2.576 is z star, so I want to know the confidence interval. So it's kind of working backwards from what we normally think. So when we look at the A chart, we usually have this number in here, and that's the confidence interval, like 95% or 90 or whatever. So I remembered that when z star was 1.96, it corresponded to 95%. So this is a larger one, so it's going to come out wider. So it's going to be more than 95%, I can see just from my memory. So this number right here is going to be negative 2.576, and I need to figure out what this value is. So what I could do is, I know it's going to be greater, again, because 95%, I happen to memorize that. Remember, we used to say in the olden days that it was 2, but the z-score for that was 2, but we learned it was 1.96 to be more exact, and on this side it was negative 1.96. So I see we've come out further from the mean. The mean is at 0, so we've come out further, so I must have a greater area here. So I looked at my answers, and I see there's only 2 that are greater than 95, and that's 99 and 99.5. Oh yeah, and then there's over 99.5. So let's hope it's one of these. I'm going to go and try 99, because I could figure that out. So if I put 99% here, that means there's 1% outside, and that's split into 2. So that's 0.5%, or 0.005 in area here and here. So I'm going to go to chart A, and I'm going to go into the body of the chart, and I'm going to see what the z-score is for 0.005. Alright, so let me do that. Well, guess what? It's between 2.57 and 2.58. So, therefore, I know that that is the correct answer. So, it just so happened that the first one I went to check, 99, worked. So if that hadn't worked, I would have went and did the math for 99.5, and then if none of those worked, I would have chosen E. But 99 worked. It led me right to that z-score, 2.576. All right, so that choice on number 9 was C. All right, number 10 was bratty beyond words. I will actually go over number 10 with you after this test, but I think it would be almost too confusing to do before. So let's just go ahead and put that one on hold. All right, hopefully, if you got any of these wrong, this discussion helped you to see why and further prepared you for Thursday's test. So, carry on, class. Over and out.